This is the structure that I decided to synthesize for my advanced organic chemistry synthesis project for this semester. Now, looking at the structure, I noticed that I have two, I guess, R substituents, both coming off of the alpha position next to the carbonyl on this, I guess, like middle structure. And we know that I can easily attach things to this alpha position next to the carbonyl by deprotonating it and then adding what we need to add. And I have two of those scenarios on either side of this carbonyl. So usually whenever I do my synthesis, I like to work backwards and I try and break up my structure into the easiest two simpler structures. And then that way I can keep breaking them down to simpler and simpler structures until I get to what can be used as my starting material. So looking at this, first I'm going to start by adding this structure on the right because I see this connection again is on the alpha position, which I know I can add things there easily. So I'm going to start off by just redrawing this side exactly the same because right now I'm not messing with it. And then, so I have my two ketones, and then there's going to be a negative right here. And then this is the other structure that I'm attaching. So before this is a negative, it's actually a hydrogen, and we use LDA, as I said earlier, to deprotonate this hydrogen. And now we know that this hydrogen is going to be the one that's going to be deprotonated, one, because you're using LDA, and also this is a very acidic proton due to the fact that it is between two carbonyls. So this is very easily deprotonated right over here in this position and allows us to go on with Gilman. So we're also going to add H0 plus. And this is going to happen through Gilman, and we're going to get the structure above, no problem. Now, I've broken it down into two simpler structures. So now I can break down these structures into even simpler forms. So let's start with the one on the left. So again, I notice I'm adding something to this alpha position right over here next to the carbonyl, but I also have an extra carbon before I add this cycle right over here. So whenever I'm redrawing my structure, I want to leave that extra carbon in there because I know whenever I do add on my Gilman, I do want that extra carbon there. So I'm actually going to make this a double bond, just like how I did up here when we used Gilman. And I'm going to attach this as my Gilman reagents. Copper lithium. Now I'm going to make this by adding copper iodine and lithium to this structure with this vinyl bromide, which I created through from a ketone actually. And I believe it's called Shigenosara reaction. I don't know how to pronounce it. I apologize. But I believe that is the reaction that we're using. And these are the reagents for that reaction to go to like work. And you need excess methyl lithium. And then I'm going to do NBS or Br2. Either one work, because essentially we form a negative over here, and then whenever you add your source of bromine, your bromine will attach. So we created our Gilman reagent, so now we can go back to this structure and figure out how we're going to make this. Now, my first thought was, since I have two ketones, I know that one of them could have been an alcohol. So I have ketone, a double bond, and an alcohol over here, which can turn into a carbonyl easily with PCC, or ketone, excuse me. And then I made this by reacting these two structures, or this one structure, and it did like an intramolecular process to make a cycle. So if I have an aldehyde and a ketone, all in the same structure, and then I first use LDA and then H0 plus, we will form this cycle, because first we're going to create a negative over here. It's going to go and attack itself. These lone pairs are going to go up, and we're going to have an O minus, and then the H0 plus is then what's going to turn that O minus into an alcohol. Now we then can create this. If we notice right over here, we do have an enone. So my first thought was to use aldol condensation, so I can break off that connection right there. And we're gonna have a ketone and an aldehyde, and that's 1, 2, 3 carbons. With another aldehyde. And then we're gonna use some kind of base, we can say LDA. And then these are all 4 carbons or less, so we don't have to synthesize those anymore. And we can move on to this right side over here. We can make this. So originally, before I had decided on even making this, my original thought was that I was gonna have this kind of structure instead of placing my double bond here. For some reason, I wanted my connection to be here. So I was gonna have some kind of vinyl halide, and then my ester is over here. But the problem was with that is I had no way of forming this vinyl halogen, this iodine on here, because originally I thought, oh, I'm just gonna use ADVOchem, it can add that easily, but it is a carbon away from the carbonyl, so it is not an enone, so I cannot use ADVOchem on this. So this was not a very good idea, and this was a lot better of an idea, so I went with this one. Now, how I made this. Again, as I was saying about how I like to break things down into the simplest forms possible, first I noticed that over here I have an ester, so I know that I can make any ester through esterification. So I just need an alcohol and an acid. So first I made a carboxylic acid, which is going to be my acid, and then ethanol would be my alcohol. And then obviously we need H plus for the reaction take place. Now we just have to make our acid and our alcohol, but luckily our alcohol is only 2 carbons, so we don't have to make it. So now just back to our acid. So again, breaking it down to what are the simplest things that we can do, I noticed that we have an enone, so I'm gonna add that. So if we have the structure originally without the enone, that can be added easily through, we will just add these reagents. So first we need LDA, we need our base, and then you need this selenium, and then you need an oxidant. So I'm going to use MCPBA. You can also use peroxide or any type of oxidant. Now I know that this could have been made through, if this was an alcohol, it could be made into a carboxylic acid through chromium O3. And then we can easily make this alcohol by reacting this cyclohexane with a bromine on it by adding Mg, and then reacting it with formaldehyde. And adding magnesium will make it into a negative. And then when that negative is going to attack formaldehyde, you will get this. And then we can easily make that by just having a cyclohexane and adding Br2 and lights. So these are all the steps that I used in order to synthesize this structure right over here. I hope you could follow along. I hope it was easy and made sense. Thank you for an amazing semester.